Alright, so we are talking about area, this whole unit, and not just these shapes, but any area. And it's not just area, it's any measurement. So perimeter is going to be part of this, but y'all know that kind of stuff. I mean, from the time you were little, how do you find perimeter? Add up all the sides. So there's not going to be a formula that I make you learn for perimeter, because every single shape would have a different formula. Okay? The difference is area, you kind of have to have those formulas, because it's not that you're always doing the same thing. It's not always length times width. It's length times width on rectangles, but not every shape is going to be length times width. So this actually has all of them, but today we're just talking about triangles and quadrilaterals. And so I put triangle here, and you probably even knew that one, but it's half of the base times height. So in a triangle, just make sure you understand that the base and the height have to form a right angle together, and that helps you decide which one is your base and which one's your height. Because the base and the height have to form a right angle. You can't measure the height without it forming a right angle. Think about when the doctor measures you. They go from the top of your head straight down to the floor. They don't go from the top of your head over to the floor 10 feet away from you, because then we'd all be 18 feet tall if we wanted to be, you know. That's not how you measure height, right? You have to be that right angle. So just remember that. It doesn't matter how the triangle is drawn, the base and the height have to form a right angle, okay? But that's a fairly simple formula, and it's actually quite similar to several of our rectangle square formulas, because length times width is what base times height could look like. With a square, it says a squared, because the length and the width are the same thing. With a rectangle, it's just length times width. But this formula is the same, except for you half it, because if you think about it, if you drew a diagonal on a rectangle, don't you get two triangles? And wouldn't they each be half the area of the whole rectangle? Yeah. That's where this formula comes from. So those are kind of the obvious ones, the triangle, the square, and the rectangle. A parallelogram is actually the same formula. The only difference is you have to realize that, and this is the reason they didn't use the AB here. With a rectangle, because it is a rectangle, the two sides that you're multiplying, the length and the width, they're always going to form a right angle. That's not true with parallelograms, because they're slanted. That's why it's not length times width. It's base times height. Those have to form a right angle. So it will never be the slanted side, like the one that's here. It's not this. Okay, the base might be this, but you have to use the height. They have to form a right angle. Sometimes they'll draw that on the inside, like there'll be a line that kind of goes right in the middle. But parallelogram is technically the same formula, but how you use it is different. Okay? Now, some of the new ones that you might not have known is trapezoid. Maybe you did, but you add the bases here and then multiply by the height and half it. So it's very similar to this formula, because remember, we talked about several different times now that triangles and trapezoids are very similar, because it's like you cut the pointy end off of a triangle to get a trapezoid. We talked about that even last unit when we moved into three-dimensional figures. There's a relationship there, and that's why this formula and this formula are actually very much the same. It doesn't look like it the way they wrote height over 2, but it's the bases, but the difference is there's 2 of them, so they add them, times the height divided by 2, just like this is. Okay? But you have to remember order of operations. You have to add your 2 bases before you multiply by height or half. Okay? So don't try to half just one of them and then add the other. You have to add first. Okay? And then the one that's the most new that you probably never did here. You may or may not have learned trapezoid when you were a bit younger, but rhombuses and kites have another formula. Now I do want to remind you, a rhombus is a parallelogram. Okay? So technically this formula for parallelogram will work for a rhombus. Okay? The reason that there's 2 formulas that would work for a rhombus is it depends on what they give you. If the rhombus is situated like this and they've given you the side length and the height, well then by all means use this one. But if they didn't give you any side length, the formula here uses the diagonals. Okay? The ones that go through the middle across from one corner to the other. That's why you get two different ones that work with rhombus, because it depends on whether they gave you a side and a height or whether they gave you the diagonals. Okay? Now, just a reminder, sometimes it's not going to look like they gave you the right stuff, but you may have to do something from a previous unit. Like you may have to do Pythagorean theorem. Maybe you have two of the sides, but the one that you need for the formula is the third one, and they form a right triangle. Maybe you have to do trig, or maybe you have to do a 30-60-90 or a 45-45-90. You know that stuff has been showing up every unit since we learned it. It's not going away. It's going to be there every unit since we learned it. Okay? And it's the same with us just talking about a similar figure. We learned similar figures way back in Unit 4, and we've been talking about them off and on since then. So there's going to be a lot of new stuff. Now the ones we're not talking about yet today are the round ones and then the regular polygons. So they're on the same thing. That way you only have one page that you have to have for your formulas. And they are going to also be in the notes in Google Classroom. But this way you have the page and you can just have it there with you. Okay, so let's look at your assignment. This one's all triangles and quadrilaterals. There's not going to be any of the polygons or circles or anything on these because we haven't talked about those yet. But look through there and pick a number that you feel like you, just by looking, you need help with. 9? What shape is 9?
A tropical?
It's a parallelogram. May or may not be a rhombus, but it's definitely a parallelogram because there's no right angles here. Now, I will tell you on this time, now that we're on this specifically, they don't necessarily have to have every marking to tell you. Like, they didn't tell you there was anything parallel, but we're only looking at quadrilaterals and triangles. So you're just going to have to look at them and guess based on that. Same with number 3. Technically, they don't tell you that's a parallelogram, but visually, you're just going to go ahead and assume it. I know I say don't assume things, but in this case, when you're looking at these pictures, it's going to be one of these shapes on here. Okay? Now, there is one quadrilateral that's not on here. You know, we had the kite, we have the trapezoids, we have all of our parallelograms, including rectangle, rhombus, square. The only one not on here is trapezium, because every trapezium is different. There's not technically a formula for a trapezium, but all you do is you draw a diagonal. If one's already drawn, that's even better. And you just do the two triangles separately and then add it together. You know, so it's not necessarily on here, but I'm saying if you did need to find area and it was a trapezium, there's not a formula for that. Just split it through one of the diagonals. It doesn't even matter which one, whichever one is easier in that problem, and find the two triangles and add them together. Okay, so number 9, this is a parallelogram, so it's base times height. And remember I said for the base and the height to make sure that it's always forming a right angle. So here's our base, but this is never going to be the other measurement you use on a parallelogram. It's this one. So this one's real simple. After you realize that, the formula is base times height. And what's our base in this picture? 2. What's our height? What's 2 times 1? 2. And what's our units? Yards. And it's area, so yards squared. Because it's yard times yard. Because I didn't write it here, but this 2 is in yards, this 1 is in yards. I'm multiplying yard times yard. That's yard squared. Kind of like if I do x times x, I get x squared. The good news is you don't really have to consciously think of that step every single time. Just remember that if you're asked to find area, your final answer should be whatever your units are squared. Okay, so if it's in feet, it's feet squared. If it's in inches, it's inches squared. Okay. What's another one?
So there's one on the back.
Then you have to convert. So is there one like that on here? Yeah. 10? Okay. How many, You can technically convert either direction. Okay, you can convert the feet to yards or the yards to feet. Since 2 of our numbers are in yards, me personally, I would convert to yards because that's less work. But do y'all remember how many feet are in a yards?
3.
How many feet are in a yards? How many feet are in a yard? It's 3. Malachi, I need you to wake up. Pay attention. Okay, so all I have to do to put this in yards is I take the number and I divide by 3, and that'll convert it. So what's 29.4 divided by 3? Put it in your calculator if you need to. 9 point what? 8? Is it 9.8 exactly? Okay, good. So that's an exact answer. So now that's in yards. So what shape is this? Trapezoid. So for a trapezoid, this is the formula we're using. So I'm going to write that down. Area equals a half of the height times the base is added. So what is the height? 8. And then what's the first base? Base 1. 9.8. Okay, so what's the second base? 4.8. So remember I said order of operations, make sure you add first. Okay? Because it's in the parentheses. And PEMDAS, P is first. So what's 9.8 plus 4.8? 14.6. Okay? Now, whether you do this as 2 steps or 1 is up to you. What's half of 8? 4. Okay? So then we just multiply 14.6 times 4. Which is what? 58 point what? 4. And this would be in yards squared. They're not going to do that too often where they make you convert, but just be aware that if you notice there's more than one type of unit in the problem, pick one of them and convert everything to that. Okay? If it's a unit of measurement you're unsure of, you know, like you don't know how many of that goes into that, then you can ask on those and I'll help you out. But that one, most of you seem to know there was 3 feet in a yard. So, you want to pick another one? 18. All right, what shape is 18? Triangle. So using our formula page right here, I know that it's half base times height. So what did I tell you that in order to identify the base and the height that they did? How do you know which ones are the base and height?
Right angle.
They form a right angle. So which of these two numbers are actually forming a right angle? 9 and 76. So this 100 is not needed. But a lot of people will make a mistake there and put the 100 as the base because it's at the bottom. And that's fine. The 100 could be the base, but if it was, you would need the height from this side like this. And you don't have that. Okay? You have it this way. So this is your base and this is your height, but notice the units. Centimeters to millimeters. Do y'all know how many millimeters are in a centimeter?
100? 1,000?
That's in a meter. 10. So you can go either direction. So which one do y'all want me to have my final answer in? Centimeters or millimeters?
Whichever one's easier.
Centimeters? Put a decimal there. Because there's 10. 10 millimeters in a centimeter. So if I divide by 10, didn't that just move the decimal over? Metric actually is a lot easier to work with than standard, but being in the U.S., we're used to like feet, inches, yards, because that's what we use. But when you actually use the metric system, it's very easy because it's everything's a multiple of 10. So if you ever don't remember, that's okay. Just ask if you don't know how to convert. The base is 9. The height is 7.6. Yes, it's 76 millimeters, but it's 7.6 centimeters. Okay, so what's 9 times 7.6? 60 what? 0.4? Okay, and then we do half of that. So we divide that by 2. Okay, and we had converted to centimeters. So that's centimeters squared. Now, be aware there are 2 right answers here, because had you chosen to convert to millimeters, the 9 would have become 90 millimeters. We would have had a different numeric answer, but they would have been equivalent. So on the ones, which they're not all of them like this, but on the few where there's 2 separate units, there will be 2 different answer choices as far as what's right.
Yeah.
So you don't have to match your neighbor on that. Okay.
Do we write today?
All right. Do y'all have any more questions, or do y'all just want to use this time to work on it? Okay. Notice on you guys, y'all have the critical thinking questions. They're bonus in the sense that if you get them wrong, no foul. If you get them right, we add points. Don't leave them blank. At least try. Okay? If you get them wrong, no points are deducted. If you get them right, bonus points are added. Okay?